Welcome back, chemistry fans. We are going to do the homework for Unit 13, topics 3 and 4. This is dealing with how we measure the strength of the acid. So this is pH, basically. So share my screen, and we will jump right into these questions now. All right, so what you see here are two different versions of the same pH problem. And then part 3 deals with a weak acid. So we'll have to deal with it in a different light. So let's get into it. So you need to first off know that pH is equal to the negative log of the hydrogen ion concentration. That's a formula we're working with. If we wanted to deal with the bases, it's the exact same formula, except we don't deal with the hydrogens because those represent acids. We would deal with the OHs, which represent the bases. And then finally, the last detail here is that pH plus POH must equal 14 if those two values come together. So with that said, we've got an acid strength, or we've got an acid concentration, which will go in here. So I'm just simply going to make this negative log of 2.9 times 10 to the negative 9. And we'll plug that into our calculator, 2.9 times 10 to the negative 9. And then we'll do negative log of that value, and you get 8.54 as our pH. Okay. Now, number 2, it's asking for the hydroxide ion concentration. But notice we don't have a POH, so it's not just the same problem in reverse. What we first got to do is put that into this equation because we do have 14 and 11.34, so it'll tell us what our POH is. It will be equal to 14 minus the 11.34. So 14 minus 11.34, that is 2.66. Okay, so that's our POH, but that's not what we asked for. We asked for the concentration amount. So what we have to do is the inverse of this log. So that means we'll do 1 times 10 to the negative POH. So we'll plug that into our calculator, 1 times 10 to the negative 2.66. And what we get, let's see, clear inverse log, negative 2.66. And we get 0.0022. That's our hydroxide ion concentration. 0.022. All right, last question. Now, this has a little bit more nuance to it because we can't just straight put in this concentration into the pH formula because it is a weak acid. So what we now have to rely on is a new formula, Ka, the acid dissociation constant, and that's products over reactants. Now, we don't have a reaction here. So what we're going to have to do is kind of create one, or we're going to have to understand that this material does not give all of its hydrogens away at once. But for every one hydrogen it does create, it's going to create one of a counterpart remaining portions away. So these, if I had 100 of the H's created, it's going to create 100 of these particles also because they're going to equally separate. Now, it may end up that you have 1 million of these, but it's only going to create 100 because the dissociation is not 100%. It's not a strong acid. It's a weak acid. So what we're going to do is we're going to take, instead of that millions and hundreds, we're going to take that product and we're going to say that we don't know what the concentration is. We'll just give them X's. So we're just going to have X times X up above. We can simplify that as X squared. And then we will divide it by the reactant amount, which we do know is 6.2, and the Ka value we do know is 3.9 times 10 to the negative 6. So now we can solve for X squared. We'll do 3.9 times 10 to the negative times 10 to the negative 6, and multiply that by 6.2, and you get 2.42 times 10 to the negative 5 equals X squared. So what we'll do to simplify that is we'll square root both sides. And we get X is equal to 0.0049. So that is our hydrogen ion concentration. It's also the concentration of the other part, but we're going to focus in on this is what we want, the hydrogen part. Now, the question is, well, what is the pH? Now we go back to our original equation. Now we can plug this in for the hydrogen. So we do negative log of that answer, 0.0049, and you get your pH is equal to 2.31. All right. So this is everything that I hope that you had learned about strong acids, weak acids, and how you can do some calculations that go with them. Thank you very much for staying with me. Talk to you again soon. Bye-bye.